I just got back in town. I was out of town. That's why I wasn't here on Wednesday. My family, we try and do one trip every summer, and my parents, my brother, my sister, and I and stuff. So we went to Estes Park in Colorado.
Oh,
You all familiar?
Place ever.
Yeah,
Every day.
it was my first time there.
We went to Breckenridge this year.
Okay.
We usually go to.
Yeah. Yeah. Yeah.
The Rockies.
Went up to the Rockies. Yeah, so anyway, but my flight got back this morning, and we got in at like 3:30 in the morning. And then I was up at 7, I was like ready to go, I don't know why. So I'm gonna like crash real hard a little bit later today. But okay, so the exams, I picked them up this morning. I was grading them in my office, I'm about halfway through them. My plan is to, after class today, I'm gonna go back to my office, I'm gonna grab them. Got to go run a couple of errands, and I'm going to go home and I'm going to finish grading them, and I plan to have those grades posted tonight on Canvas. So far, it looks like about 80% of the class is doing really, really well. I can tell there's a few students that are struggling with it, but just wait for me to finish grading it, and then we'll discuss it next time. I think that last problem threw everyone off, that graph problem, kind of caught people by surprise. So I'll see how I'm going to incorporate that into the grade. I may just count as a bonus or something like that. Okay, any questions on the exam or anything that I can address now? Yes?
For the final, the question's going to be taken from like each exam and kind of like changed a little?
Yeah, let me look. I believe on our final is right after our third exam. So that means the final will include mostly things from each exam, but I will kind of help you. Everyone will have their exams by that time, and I'll say, okay, everyone, look at your exam 1. Let's focus on these problems for the final. It won't be everything from each exam. Okay? Did that answer your question? Okay. Anything else? Did you take the whole time? You said you were here the longest,
Yeah.
right? So you took the whole time?
Yeah. I was 20 minutes before.
Okay. So y'all felt like the test wasn't like too long? Like it was okay? All right. Okay. All right, let's get down to business. So today we're going to start doing something. I don't want to say what it is yet. I won't give it away. But I wanted to start off by trying to kind of motivate like why we're going to do what we're doing today. All right, so when it comes to solving equations, we already know how to solve linear equations. And that would mean that you have an equation, you have one variable in there, and you're trying to well, you look at it first to see that all the x's in here are raised to the first power. If there's not a number up there, that means it's just x, not x squared, not x cubed, right? So these are called linear equations. And the way we solve these, we've done. The technique we have is that we just want to get x by itself on one side of the equation, right? So we have to use different properties like distributing this 4 through and then collecting like terms and moving things around and then ultimately get x by itself. All right, but it's usually addition and subtraction, multiplication, division is required, moving things around, right? But what happens when we get an equation that is nonlinear, right? Something like this. So now we have x cubed, x squared, there's an x in there. Like, how do we go about solving this? And it turns out that we cannot use this technique. You cannot get x by itself. It's usually not possible. So do we have a way of doing this? And the answer is yes, we do. But we have to use a property that I'm about to show you. And once I show you this property, it'll hopefully help convince you why we actually are going to need to factor. Right? That's the big word for today is factoring. But why? All right, so let me just put something up here. What if I tell you that I have two things, I'm going to call it A times B, and what if I tell you that when you multiply those two things, you get 0? Is there anything you can tell me about A or B? One of them has to be 0? One of them has to be 0. Does anybody disagree with that? Think about it. Is it possible to multiply two numbers together and get 0 without one of them having to be 0? Let me kind of approach this a different way. What if I told you that two numbers had to multiply to be 1? Would one of these have to be 1?
No.
Not necessarily. Can you give me an example of two numbers that would multiply to be 1 where neither one of these would be 1? 0 times 0 would not be 1, though. 0 times 0 would be 0.
0.5 times 2.
Okay, so 0.5 times 2. So how about I do it this way? 1/2 times 2 is 1, right? Half of 2 is 1. So this is an example where we have two numbers that multiply to be 1, but neither one of them is 1, right? Here, what I'm saying to you is that if two numbers multiply to be 0, one of them has to be 0. Has to. There's no way around it, all right? And you can try, if you're not satisfied with that or you're not convinced of it, you can just start trying, give me any number, 3 times. How are you going to make that equal to 0 without this being 0? There's no way to turn 3 into 0. Does that make sense? So this would have to be 0. So this right here is a very important, important property. It's so important we have a name for it. Okay, it's called the zero factor property. And all it's saying is that if you have two things that are being multiplied, each one of these is called a factor. All right? The zero factor property is saying that if you have two factors multiplying together here and that they equal 0, then one of them has to be 0. All right? So I will write that down underneath that. Let me erase this. So zero factor property says if A times B equals 0, then A equals 0 or B equals 0. One or the other. Now they could both be 0 also, but one of them has to be. All right? Has to. I'll leave that up there for right now. So let's take a look at something oops, let me silence my phone. I forgot to do that. All right, so you know what, we'll come back to this. All right, so let's look at an example. What if I say 4x equals 0? Then what does x have to be? 0. Do you see that this is this property? See, we're really saying 4 times x equals 0. And that means one of those has to be 0, and obviously 4 is not 0, so that means x would have to be 0. So this means x is 0. Now you could get that algebraically by just dividing both sides by 4. And that would give you that x on this side equals 0 divided by 4 is still 0. So, but I want you to see the property in this, all right? So let me give you another one. What if I have x parentheses x minus 2 equals 0? So do you see two things being multiplied here? Okay, there's multiplication right here, isn't there? Even though we don't write it. And so I want you to try and like squint your eyes a little bit. And I want you to see that this piece right here is kind of like the A. And this entire piece in parentheses is like the B, and they're being multiplied, right? So you have two factors being multiplied that have to equal 0. What does that mean? One of them has to be 0, right? So what we do when we see something like this, and you've probably seen this in the past, you've been told to set each one of these equal to 0. Have you ever been told to do that? Well, what we're doing is we're doing this. We're saying, okay, if two things multiply to be 0, then one of them has to be 0, so let me set them both to 0. So what we would do is set this x equal to 0, and then I like to write a line, or just draw a line splitting. It's kind of like two trains of thought here. Either x has to be 0 or x minus 2 has to be 0. And each of those can be solved. This first one is already solved. There's nothing to do here. This one, what type of equation is that?
Linear.
That's a linear equation. So now you're back to a linear equation, right? And this would give you x is 2 if you solved it. Just move the 2 over, right? Now, let's go back to this problem. This is the way I presented it to you because I wanted to really emphasize the A times the B, right? But let's say I had asked you to multiply this x through. Could you do that? Yes? And if you did that, what would it look like? X squared minus 2x equals 0, right? If I would have distributed that x through. Now, if you look at this equation, that's not linear, right? That's not a linear equation. But we actually have the solutions to this. Here are the 2 solutions. If you plug in 0, will this be true? 0, 0, that'll be 0. This is true. If I plug in 2, will it be true? 2 squared is 4. 2 times 2 is 4. 4 minus 4 is 0. So it works, right? So the way that we would, if we started with this and wanted to get to this point, what would have been my first step to go back from here to here? Factoring, right? That would have been GCF. We would have pulled the greatest common factor. So that would have been something like, I could have put that on the test and said, factor that using GCF, right? And you would pull an x out, because that's what they have in common. Then you would have had x minus 2. But then we still have the equation, equals 0. Then you use this property, and then you break it down. Understand? Okay, so really, when we go to try and solve nonlinear equations, nonlinear, our technique is going to be doing some sort of factoring so that we can then implement the 0 factor property and set the factors to 0. All right? Now, I'll add one more thing to this. What do you think would happen to this property if I said A times, let me try and squeeze it in here, A times B times, well, I'm not going to squeeze it with a marker that doesn't work. Let me see here. Yeah. What if I said A times B times C equals 0? Do you think that this property would then say, then A must be 0, or B must be 0, or C must be 0? What do you think? If there are 3 things multiplied to be 0, do you think that you would just set each of the 3 to 0?
Yes.
Yes, that's exactly right. And if there were 4 things being multiplied together, you would set all 4 to 0, equal to 0. So this property extends out to however many factors you have. Now in this class, we won't ever have more than 3 factors. We will never have more than 3 things we set equal to 0. But in like a regular college algebra class, sometimes they have 6 factors, you know, and so it can get more complicated. All right. So if we're going to do solving nonlinear equations, if we're going to have any hope in doing it, we are going to need to be decent at factoring. If you're going to be an engineer, you need to be very good at factoring. So what we need to do now is discuss how to factor. Make sure everyone's got a basic idea of factoring down. And just from talking to you right now, I can tell some of you already do, but it doesn't hurt to go through the steps. So here are the steps for factoring. It's cold. Am I cold? Is it just me? Okay, steps for factoring. All right, anybody know the first step for factoring? Anytime you want to try and factor something, you always do this first. We've done it, yeah, GCF. You always try and find a GCF first. Factor out GCF, greatest common factor. So we've done this, yes? All right, that's always the first step. The next step is to count the terms in the parentheses. Did I spell that right? E? My 8-year-old daughter's got me playing this game on her iPad called Wordscapes. Anyone played that before? No. It's like crossword, whatever. She's a better speller than I am. She's 8 years old. That's why I'm not an English major, though, right? That's right. We all have to be like good at our thing, you know? When it comes to English, forget it. I had a problem with that I before E thing. What's that?
I before E except for after C.
I before E except after C. Y'all heard that before?
Yes.
So, that's right.
No, yeah.
Is that right?
No.
I have to write everything down. I just spell like crazy. I have to write everything.
Well, what's the because I know the rule is I before E except after C. That's what I've heard, right? But it doesn't always work.
That doesn't always apply.
So what? Okay, so why do you call it a rule? Why is it a rule if it doesn't always apply?
It's elementary school. Come on
Right?
now.
I know. I'm just saying that's what I didn't do good with. Okay, is rules that don't always apply. It's like my dad told me one time. You know, stop signs. You driving stop signs. He told me that the ones with the white borders around them are optional. So you can't have something like that, right? A rule that sometimes applies. Okay. All right, so we're going to count the terms in the parentheses. So I'm going to continue putting the steps up here. They're going to seem confusing because we're not going to have any examples to work through. But once you see some examples, these steps will make a little more sense, I hope. All right? So we're going to count the number of terms. And in this class, we're only going to ever get 2, 3, or 4 terms. That's it. Okay? That's what we're going to deal with. So we have, from this step 2, if there are 2 terms left, look for difference of squares. If you don't know what that is, don't worry about it. I'll tell you in a second. Sum of cubes or difference of cubes. All right. And again, I will illustrate what each of those looks like with examples, all right? That's if we do a GCF, okay? And then after we've done GCF, we had in the parentheses 2 terms left. If we had 2, then we're looking for this right here, okay? Now, if there are 3 terms, we use what we call the AC method, which again, you may not know what that means, so I'll go through that. And then finally, if there are 4 terms, anyone know what we do with 4 terms?
Group factor?
That's right, we try what's called grouping. Okay? So we have all these different things now that we're going to have to be at least somewhat familiar with today. We're going to want to be comfortable with, first of all, pulling GCF out of something. And then once we do that, counting, and we're either going to be looking difference squares, sum of cubes, difference of cubes, AC method, or factoring by grouping. It can be any of those things, all right? So you ready to get started? Okay. Notice that this is how we factor, all right? This is not, we're not solving equations yet. This is the technique that we need to get from that one step to the next, so then we can use that zero factor property. All right, so let's start with our first example. And let's go back to the one that I had up here just a second ago. We'll go slow here. I think we have 2 full class periods for this stuff. So we'll make sure we got it. All right, what was it that I had? X squared minus 2x equals 0? Or, yeah, just...
X cubed.
Oh, yeah, no, not that one. The one I did where... We'll get to that one. The one I did where I did x and then in parentheses x minus 2?
Yes.
And then equals 0, right? And then I multiplied through. So when we multiplied it through, this is what we had. I'm not going to put the equal 0, all right? I'm just going to put that expression up there, and I'm going to say factor. All right? So when we factor this, first step is GCF. So we've already done this. What do they both have in common? X. So I pulled that x out, and I'm left with x minus 2. So how many terms did I have left after I did the factoring? 2, right? 2? That's right here. We have 2 two terms in here. Since I have two terms, I'm going to look to see if this is a difference of squares, a sum of cubes, or a difference of cubes. Now, what is that? Well, in order for it to be a difference of squares, this would have to be squared. For it to be a sum of cubes or difference of cubes, this would have to be cubed. And since it's not, we are done. Okay, we have already factored it. All right, so I just wanted you to see that. If we're following that process, what's left is not a difference of squares, sum of cubes, or difference of cubes. So we are done. Nothing else we can do. All right, so that's it. This would be the answer. If I asked you to factor that, that would be the answer. All right, now let's go to a different one. And let's go with, I think I'll make one up. X cubed minus 3x squared plus 4x minus 12. Now, it looks like I'm throwing you completely to the wolves here, right? Like we started with this little thing and all of a sudden, this ugly looking thing. And that's because when it comes to factoring, we actually like to start with the four terms first. Because if we do four terms, what is it that we have to do if we have four terms? Grouping. Grouping is very useful. And we actually need to know how to do grouping in order to do three terms. It's weird, but we'll start with this. Okay, so here we go. Do you have a GCF? No GCF, right? There's nothing that is common to all of these terms that you can pull out. So step one is done. There's no GCF. We good? Sure? Okay, so now we count the terms. We have four terms. So we're going to try grouping. So I'm going to try grouping. Now, if you've never done grouping, I'm going to try and present it to you in a way that you can learn it quickly. If you have done grouping, stick with what you know. I'm not here to, try and confuse you. But here's how grouping works, is the way I teach my students, is you look at the terms, okay? And after the second term, I just draw like a slash. And I make sure it's before this symbol. If it's a plus or a minus here, just make sure that slash goes before it. And what that slash is going to do is it's going to break your problem into two groups now. You're going to look at this first group, and you're going to try again to do a GCF. But just on these two, not these. All right, so is there a GCF here? Okay, what is the GCF? X squared. So what you do is you write x squared down, then you put a parentheses, and enough space here for two pieces. So what would I need to put here to get this back? X minus 3. Okay. That good? Sure? Okay, next step is to look at these two terms and see what you can pull out of these two. A GCF again. So what do those both have in common, just these two? A 4. Positive 4 or negative 4? Positive 4, right? Since it has a positive 4, I'm going to put, and you have to put the plus 4. If it was a negative 4, you'd have to put the minus, all right? So I'm going to put plus 4, and then again, parentheses, what would I need in here to get this back? X minus 3. Right? So what we're saying is that this is equal to this. And I mean, you could just check it yourself. If you multiplied this through, you get back this, and if you multiply this through, you get back that, right? And you put them together, and you'd be there. So we haven't really done anything other than change the way it looks. But the next step is actually going to be very nice for us. So this is where things might, I don't know. It just depends on, again, on the way it's taught. I know some of you already know what to do. So does anyone want to share with me what you've been taught to do at this point?
Just great common factor in the x minus 3 is 3.
Okay, so what do you want me to write down?
Parenthesis x minus 3,
Okay,
and then close parenthesis and open parentheses, you're going to put x squared plus 4.
so another parentheses and x squared plus 4. So what just happened here? See, this is the step that most students we can teach you to go from here to here, and most students can just kind of like mimic what just happened. But like algebraically, what just happened? Because that is correct. But what happened? Like, can you explain to me what we just did?
You factored out the GCF.
Where? I thought we did that. Thought we didn't have one. I'm challenging you. I thought we didn't have a GCF.
No, but when you
We
broke
do?
down to the second, the way it looks, how it's equal right there.
Yeah?
That has the greatest common factor.
What's the greatest common factor here?
X minus 3.
Oh, so they both have x minus 3.
That's
So you actually, what, like pulled that whole thing out?
pull it out.
Okay, so that's the part that most people miss. Okay, so let me write something down here. This is, I think this is easier to see. Let's say I had x squared times m plus 4m. These both have an m in them, right? So if I told you to GCF this, you would pull the m out, and in parentheses you'd write x squared plus 4, right? If you understand that, that's exactly what we did to get from here to here. Except that this is the m, and this is the m, right? They both have like x squared times something plus 4 times that something. We're pulling that something out. There it is. That's the m. And then we have the x squared plus 4 in parentheses, just like here. So it's kind of weird because we're pulling something out that's in parentheses, a big chunk of stuff, instead of just like one letter. But it's the same process. All right, so this is it. We have actually factored. If you think about what the ultimate goal of this is to try and use that zero factor property later, we'd be wanting to have something times something equals 0. And we would have it. We'd have this, right, times this equals 0. Notice that we didn't have that here. Do y'all see that the line above, we don't have that? Like this is not like A times B. This is like something times something then plus, and that kills it. That's why we can't use zero factor property right now. But we get to here, now we can. So we're almost done. We're not completely done though. We need to make sure that both of these can't be factored any further. So this is two terms, isn't it? Two terms, we look for difference of squares. Sum of cubes or difference of cubes. And since the x is not cubed or squared, we're done. What about this one though? It's squares, right? I mean, you have squared here, but it's not a difference. It's not minus, it's plus. And there is no way to break down a sum of squares. If you go back and look what I wrote on the board earlier, it was a difference of squares, sum of cubes, difference of cubes. There was nothing there about sum of squares. So if you ever have a sum with the x squared, two terms, we are done. It doesn't factor any further. So this would be our answer. Okay. Let's try something else. Let's stick with the four terms. But this time, it's going to look a little different because I'm going to put another letter in here. I'm going to put another variable in here. How about this? 2xz plus 6yz plus x plus 3y. Okay, so I know that there's a bunch of different letters in there. Don't freak out. Our goal is to try and make this look like something times something. All right, things being multiplied together instead of a bunch of additions and subtractions. So, do you see a GCF? Is there a number that goes with all of these other than 1? Well, can you pull a number out though? There's not a number that you can factor out. How about letters? X here, no X is here, right? So it's not common. How about Y's? Well, there's one here and here, but there's not one in those two. Z, they're not in all of them. So there's nothing we can pull out, right? There's no greatest common factor. So there are four terms. So we slash it right past the second one. And we try and do a GCF on those two. So do we have a GCF on those two? 2?
2z.
2z. If I pull out a 2z, what would I be left with? If I pull 2 and z out of this one, what would I have? X, and then plus 3y. Agreed? Okay. Now, what about the next one? This is tricky. What about the next one? Is there a GCF in those two?
One.
1, right? But we've never pulled a 1 out before, have we? Anytime we've had a 1, we've always just said we don't care, right? But here it matters because we need to have some symbol here, either a plus or a minus right here. And then our greatest common factor, and then a set of parentheses. So because we need this to have a symbol, we have to put plus 1. All right? Now you don't need to write 1, but I'm just trying to help stress what's happening. We're noticing a greatest common factor of 1 so that I can have an addition symbol here, and then parentheses, and then what goes in there? X plus 3y. Now, these two things match, right? That's like the m earlier from the previous example, so we can pull that m out in front. So this is x plus 3y. And then what? In parentheses, 2z plus 1. So sometimes students are taught that whenever you get it to here, you just write down whatever they have in common, you just write it down, and then write a set of parentheses, and just put the two things that are in front in that parentheses. And if that's the way you were taught, great. I was just trying to show you what was happening. Like it was actually a GCF coming out. Okay, now each of these are two terms. These are not difference of squares, sum of cubes, or difference of cubes, because none of the variables are squared or cubed. So we're done. This okay? All right, why don't I give you one to try? Actually, I'll give you two, because I know some of you have got this down already. Let's go with 15xz plus 20x plus 6yz plus 8y. Okay, so factor that. And then the other one, if you finish that one, try this example. Let's see here. those are the two problems worked out. So if you have a question, you can raise your hand. I can come by and clarify anything. Yes.
Is there an instance where you already have one of the factors, but the other half is not going to be equal? Like you already have 3z plus 4, but can there be a possibility where the other side isn't going to have 3z plus 4?
I'm glad you brought that up. I was actually going to put something like that for the people who were done to see what would happen. Yeah, like what would happen? Like if I changed this to 12, let's say. You know, like what if this was 12 here instead? Then what would you have here? You could probably pull out what instead here? 6. And then this would just be z, wouldn't it? And then this would be 2. And then they don't match, right? So what would happen in that case? Yeah, you couldn't, basically grouping would fail. All right, so grouping, notice in the instructions I said if you have 4 terms, try grouping, because grouping can fail. And that, again, if you wanted to know how to continue with that, that would be for the Math 1414. They have to learn a whole other technique for when that fails. It's called synthetic division, and they use something called the rational zero test, and they go through this whole process trying to find these things. So, but for us, don't worry, I'm not going to give you any that do that. Yeah. Okay? But it does happen. Okay. Can I proceed, or are y'all all right with this? You sure? Okay, let's talk about those 2-term possibilities, because I've tried to avoid them intentionally, but now we need to discuss how we actually factor these things called difference of squares, sum of cubes, difference of cubes. So let's start with the difference of squares. All right, the difference of squares. So I'm going to give you examples. And after I give you the examples, I'm going to give you the formula. Sometimes we give the formula first and then do examples. I'm going to actually try and get you to see the pattern before I give you a formula. So let's say we're asked to factor x squared minus 4. Okay, you see 2 terms, right? There's no GCF here, right? There's nothing we can pull out. So this is just sitting there, 2 terms. If we're trying to factor that, we notice that it is a difference, right? We have subtraction between these two, and that this is something squared now. Also notice that 4 is something squared, right? 4 is 2 squared. So whenever we see this, it's going to automatically turn into 2 things in parentheses. It will turn into x plus 2, x minus 2, right? So basically, if this is the squared, it's just going to become x and x here, right? And then this was 4, so 2 squared is 4, so we put 2 here and 2 here, and then we just put a plus in front of one, or in between one group, and a minus in between the other. Now, why does this turn into this? Well, what if you FOILed this? What would you get? X squared, and then minus 2x, and then this is the kicker right here, plus 2x. See, these two are going to wipe each other out. And then our last multiplication, we get our minus 4. So these two are gone, so you get x squared minus 4. So there's your difference of squares. Let's do another one. How about x squared minus 1? Is that a difference of squares? Yes. So it should turn into 2 things. It should be x here, and then what's the number I'm going to put here and here? 1, right? Because you're trying to figure out, like here we were saying what squared is 4? 2. Here we're saying what squared is 1? So we put 1 here, and then plus here, minus here. You can do minus and plus. It doesn't matter which one you do. I always do plus and minus. How about this one? All right, now that's a little harder. Do you see 2 terms? Do you see things being squared here? Things squared here? Okay. So this is going to turn into two things in parentheses. Let's start with the number in the back. What would be the number that would go here and here? 9. Okay. Y'all agree? We're going to have a plus here and a minus here. But what about the beginning? It's not going to be x this time. It's going to be 2x because you have to get the 4, right? So that means you need a 2 times a 2 again because you're going to have 2's here and here. So when you do that first FOIL, you need to get 4, right? So you need 2 x's here and 2 x's here. That way when you FOIL, you get your 4x squared. And then the middle terms will always cancel out, and then your last term will be negative 81. That all right? Do another one. How about negative 49y squared plus 4x squared? Is that a difference of squares? So that plus sign in the middle is a little confusing, right? So let me see. Is this the same as this?
Yes.
That's the same thing, isn't it?
Yes.
And now do you see that it is a difference of squares? Two terms, right? Two things. Subtraction, we got things squared in both. So we'll have two sets of parentheses. And, what am I going to put here and here so that I'm going to get this out when I multiply? 2x. And what am I going to put here and here so that when I multiply I get this? 7y. And then plus or minus, or plus and minus, whichever way you want to do it. That all right? You sure? Now the formula, okay? The formula for difference of squares is this. If you have something squared minus something else squared, it will always turn out to be two sets of parentheses, a plus b, a minus b. So that's your formula. So if we go back to this, right here, this is the part that gets tricky. What is a? Like this is something squared minus something squared, right? But what is a? What is a? When we look at that, what's a? What's a going to be?
4x.
Not 4x. Not just x.
4x squared.
What was a? It was 2x, right? It was 2x. 2x is a. And then what's b? 7y. Right? So that's, I think if you just do this and find the pattern, most students can pick that up. Once we start using the formula, I think it can be a little bit confusing. It just depends on you and your brain how it works. Okay. Now, the reason why I want you to see the formula is because the formula for difference of squares, I think I can show you a pattern. Most students will pick that up. When we get to the cubes one, it's harder. So let's talk about that. How about sum of cubes? Start with sum of cubes. Now I noticed in the homework I didn't see any cubes. Yeah, they don't do any cubes, sum of cubes or difference of cubes in the packet. But I'm not married to the packet, so I don't have to do what it says. So I get to do sum of cubes if I want to, all right? So let me give you an example of a sum of cubes. X cubed plus 8. All right, that's definitely not a difference of squares, right? It's not two things with subtraction and then these things are squared, right? They're cubed. Is that obvious? X cubed? Now the question you have to ask yourself now is that 8 something cubed?
Yes.
What? 2, right? 2 times 2 times 2 is 8. So this is the sum of two things that are cubed. So what does it turn out to be? Well, it's not as nice as this, unfortunately. It's not just like two sets of parentheses and you just kind of plus and minus. It's not that. Do you know it?
Can you just put like x plus 2 in parentheses and cube.
Oh, like this? I wish, man. That would be great. I wish that's what we could do, but we can't. Because I know what you're trying to do here. You're trying to say, okay, this would be just cube the x and cube the 2. But that's not what this means. This means take x plus 2 times x plus 2 times x plus 2, and you have to do FOIL. And then you'd have to FOIL again or expand, and it would at the end of the day would not turn out to be this. Yep. So unfortunately, no. But I do have some good news. That is the first thing you would write, x plus 2, just like that, but not cubed, just x plus 2. All right? And then after that, x squared minus 2x plus 4. What? Okay, what just happened? I'm using a formula. That's what's happening, all right? So unfortunately, with the sum of cubes, I need to give you the formula because the pattern, it's not as easy as the difference of squares. So may I put the formula up here for you? Okay, the sum of cubes formula goes like this. If you have a cubed plus b cubed, it will be equal to a plus b. Now notice, a cubed, right? B cubed. We put the a and the b here. So like for here, what was a for us here? X. What was b for us here? 2, right? So that's why I put x plus 2, right? A plus b. Followed by a squared minus a times b plus b squared. And that's the formula. And I'm sorry, that's what it is, but that's what it is. We don't get to make these things up. Okay? I will not ask you to memorize that, but I will ask you to have it available. And if we do cheat sheets, I will allow you to have that. Okay? All right, so let's see how I did this here. I'm recognizing that when I'm looking at this, my a is actually x, right, in the formula? And here, my b is actually 2. So we already said this is a plus b, right? Then parentheses, a squared, which means I'm going to square x, right? X squared. Then I'm going to say minus a times b. Well, here's minus. What's a times b? What's these two multiply? 2x. See that? And then I put plus the b squared. And what's b squared? 4. I think another one is in order. How about x cubed plus 1? So I think with the sum of cubes, you need to identify what a and b are first. So what's a for us here? A is just x, and what's b for us here? 1. So let's just crank out this formula here. This will be a plus b, so what's that? X plus 1, parentheses, x squared minus x, that's 1 times x, and then plus 1 squared, which is 1. A plus b times a squared minus ab plus b squared. All right, so what do you think will happen now if I change this instead of the sum of cubes, I change it to the difference of cubes? Do you think my formula is going to change? Yes, it is. Let me show you how it changes. I'm going to do all the changes in red. Okay, if this is a minus sign instead here, do you think this changes? It actually does. This becomes a minus. That's good news so far, right? This does not change. It stays a squared. Do you think this changes? What does your gut tell you? No? Yes? So it's kind of a coin flip. It does change. Okay? So this is going to become a plus. So far, okay? So it's like the same formula we just used, except if this is a minus, then this becomes minus, then plus. And then what do you think this? It turns out to not change. I know. This is the special one. This one right here stays the same in both formulas. And that's just the way it is, okay? I'm the messenger. I'm delivering you the message. I did not make this up, all right? All right, so let's try one of these. I'll do x cubed. Let's do x cubed minus 8, and let's just see the difference between that and what we just did. So x cubed minus 8, using this formula. X is still, a is still x, right? And b is still 2. So my formula now says what? X minus 2, good. And then here, x squared, this time plus the x times the 2, so 2x. And then plus again, because it's plus in both formulas, what? 4. That all right? Now, if you don't believe that this is true, if you don't believe that this is this, you could actually multiply this out, and it would work. I'll do it just for this one. If I multiply this times this, I get x cubed. This times this, I get plus 2x squared. This times this, I get plus 4x. Then I move to this one. In here, negative 2x squared. Here to here, minus 4x. Here to here, minus 8. And a lot of things go away here. This is gone, this is gone, this is gone, this is gone. All you're left with is x cubed minus 8. So that's just to verify that it does work. But, all right. I don't plan on hitting y'all too hard with the sum and difference of cubes. It's just if it shows up, I want us to know what to do with it, all right? I would definitely be prepared for the difference of squares, though. All right, let's do an example. I'm going to let you work this one. The instructions here are to factor, all right? Factor that. Go through, when I started this whole thing with factoring, I gave you a set of steps, didn't I? Follow the steps. See what you can come up with. I've unmuted my microphone. Do you want me to work it out, just so you can check? Okay. If you got that far, that's good, but it's not done. So that is completed right there. So we've got that GCF comes out first. What we're left with is two terms. We check, it's a difference of squares, so we factor it, and the 3x still remains out front. Each one of these is linear. They're not they're not square, they're not cubed, so we are completely done. And see, if we were actually solving an equation, which is our goal later, then to solve this, we would do this, and then we would set each of these three things equal to 0. And we would have three different answers. We're not doing that right now, but that's the ultimate goal. Okay, questions here? Sure? I'll give you one more of these. Oh, oops. Try that. That looks pretty bad, right? X to the 5th. Don't forget the first step of this. If you finish